Hi, welcome to this Corbettmaths video on differentiation. In this video we're going to look at some differentiation questions, but in these questions we're going to need to do a little bit of rearrangement before we can do the question. Before you watch this video, I highly recommend you watch two of our videos. One of them is called an introduction to differentiation, so showing by first principles how to differentiate. And the second one is differentiation 1, where the general rule is used. So this rule, if you've got y equals x to the power of n, the dy by dx, the gradient function, is equal to n x to the power of n minus 1. In other words, bringing down the power and reducing the power by 1. So let's have a look at some typical questions now where we're going to have to do a little bit of rearrangement before we start the question. So we've been given y equals x cubed bracket x minus 8, and we've been asked to find dy by dx. Now on first inspection this looks quite difficult, but actually if we expand the brackets it turns out to be quite straightforward. So let's expand the brackets to begin with. So y equals, expanding, so x cubed times x would be x to the power of 4, and x cubed times minus 8 would be minus 8x cubed. And now if you look at it, this is just like the questions towards the end of the last video, differentiation 1, where we can just use the general rule of bringing down the power and reducing the power by 1. So dy by dx equals bringing down the power, so that's going to be 4x, and reduce the power by 1 cubed. And then here we've got minus 8x cubed, so bringing down the power, so minus 8 times 3 would be minus 24x, and reduce the power by 1 squared. And that's it. So if you have brackets, you may need to expand those before you can differentiate. Okay, next question. So in the next question we've been given y equals 2x minus 5 all squared. And what we're going to do is we've been asked to find dy by dx. So if we expand this bracket, and remember if it's squared we have to multiply the bracket by itself, then we get something that's much more easy to differentiate. So y equals brackets 2x minus 5 bracket 2x minus 5, because we're squaring it, we're timesing it by itself. Then if we expand the brackets, we're going to get y equals, well, 2x times 2x is 4x squared, 2x times minus 5 which would be minus 10x, minus 5 times 2 which would be minus 10x, and minus 5 times minus 5 which would be plus 25. Simplifying this would give us y equals 4x squared minus 20x plus 25. And now we need to find dy by dx, and this is perfect. So we can do dy by dx, and we can bring the power down. So 2 times 4 is 8x, and reducing the power by 1, well, it was a 2. Reducing it by 1 would be 1, and we tend not to write 8x to the power of 1, we just write it as 8x. Differentiating minus 20x, so that's straightforward, that's minus 20. And remember, if you differentiate numbers or constants there, they just become 0, so we can just ignore them whenever we're differentiating, so that's just going to be 0. And that's it. So dy by dx would be 8x minus 20. Okay, let's have a look at our next question now. So our next question says, well, this time it involves fractions rather than brackets, and it says y equals x to the power of 8 over 2 plus x cubed over 3, and we've been asked to find dy by dx. On first inspections this looks quite difficult, but if we actually do a little bit of rearranging, it becomes something that's quite straightforward to differentiate. So if you divide by 2, it's the same as timesing by a half, or if you divide by 3, it's the same as timesing by a third. So let's write this as y equals a half times x to the power of 8 plus a third times x to the power of 3. So instead of writing divided by 2, we're writing a half, and instead of writing divided by 3, we're writing a third. So we're just writing the fraction in front of the x term. Okay, now we can differentiate this quite nicely. So let's find what dy by dx is. So again, we're going to bring down the power. So we've got a half, and we're going to times it by 8. Well, a half times 8 is equal to 4x, and reducing the power by 1, that's going to be 7. And this time we've got a plus a third, and we're going to bring down the 3. So a third times 3 is 1, because 3 thirds is a whole. So plus 1. Now I'm not going to write the 1, so I'm then going to write x, and I'm going to reduce the power by 1, so that'll be squared. And that's it. So if you've got fractions, it can be sort of a bit easier if you bring the fraction or the sort of in front of the x term. Okay, let's have a look at our next question. So let's have a look at our next example now. We've been given y equals 1 over x cubed, and we've been asked to find dy by dx. So this question again looks quite difficult, particularly as we've got x's on the denominator. But if you've got x's on the denominator, you can do something about it. And I just want to show you that if you've got 5 to the power of negative 2, if you were given that question, remember negative indices, that would be the same as 1 over 5 squared, because the negative power means 1 over. So if you have y equals 1 over x cubed, we can actually bring the x's up and write y equals x to the power of minus 3 by just giving it a negative power. So if you have x's on the denominator, you can then just bring them up by giving them a negative power. So now we've got y equals x to the negative 3. You might recognize this question from the differentiation 1 video. We've actually done this question already. We just need to define dy by dx. We'll bring the negative 3 down, so that's minus 3x, and then reducing the power by 1, that'll be negative 4. And that's it. Now, actually, in this question, we were given y equals 1 over x to the power of 3. I'm actually going to give my answer in a similar form, so I'm just going to take this a little bit further. And I'm going to write dy by dx equals, and I'm going to bring this x to the negative 4 to the denominator. So I'm going to write minus 3 over x to the power of 4. And I've just put the minus sign at the front of the fraction. I tend to write them there rather than up on the denominator. So that's it. So if you have got a fraction where you've got x's on the denominator, you can bring them up by giving them a negative power, and then you can differentiate. And if you get a negative power in the answer, you can just put that on the denominator. So next question says y equals the square root of x, and we've been asked to find dy by dx. Now this question looks quite tricky to begin with because it doesn't have a power for the x, but the square root is equal to the power of a half. So if you have the square root of x, that would be the same as y equals x to the power of a half. And you might know that from fractional indices. If it was the cube root of x, it would be to the power of a third, and so on. So now we know that y equals x to the power of a half, we can differentiate quite nicely. So dy by dx equals, bringing the power down, that would be a half x, and taking 1 away from the power, well, a half take away 1 would be minus a half, so minus a half. And that's it. So dy by dx equals a half x to the power of minus a half. Now this does have a negative power, so you could rearrange it if you wanted to, bringing the x down to the denominator. So we could write dy by dx equals, and because it's a negative power, you can put it on the denominator and make it a positive power. So it's going to be 1 over 2x to the power of a half. Also, to the power of a half, you know that's equal to the square root. So I could write that's equal to dy by dx equals 1 over 2 times the square root of x. So, you know, depending on how you might need to leave the answer, you could leave it as a half x to the power of minus a half, or you could rearrange it into the form dy by dx is equal to 1 over 2 times the square root of x. Okay, our second last question. So our next question, we've been given y equals 4 over x squared, and we've been asked to find dy by dx. Again, this looks quite difficult because the x's are on the denominator, but as we've seen before, if they're on the denominator, that means we can bring them up and they'd have a negative power. So we're going to write y equals 4x to the power of minus 2, because obviously x to the power of minus 2 would be the same as 1 over x squared, and times it by 4 would be 4 over x squared. Okay, now we're going to differentiate. So dy by dx equals, bringing the minus 2 down and timesing the 4 by that would be minus 8x, and reducing the power by 1, well, that's negative 2, take away 1 would be negative 3. Again, we could leave our answer like that, or we could bring it back down to the denominator and write minus 8 over x cubed by bringing the x cubed to the denominator. And that's it. Okay, and our last question, we've been given y equals 7x to the power of 4 minus 9x cubed over x. Now in this question, because obviously we've got the big divide by sign, we just need to divide both terms by x, and then we can differentiate. So we're going to write y equals 7x to the power of 4 divided by x would be 7x cubed. Remember, this is x to the 1, and when we divide, we take away the powers, so 4 take away 1 would be cubed, and then subtract 9x, and 9x cubed divided by x would be 9x squared. Now that's what y is. We need to find dy by dx, so we can just differentiate this. So dy by dx equals, bringing the 3 down and multiply them. So 7 times 3 is 21, x, reduce the power by 1, squared. And we've got minus 9 times by 2, that's minus 18, x, and reduce the power by 1, well, that's just x to the 1, or we could just write x. And that's it. So in these questions, some of the questions needed rearranged before, all of them actually needed a little bit of rearrangement before we could differentiate it by using the general rule. And sometimes whenever we have got the answer, it can sometimes be useful to rearrange it into a slightly nicer format, particularly if you've got x's with negative powers. It can be quite nice to put them back on the denominator with a positive power.